all right. So again, what I want to do is try and go through at least one of each type. And we'll start with proving a theorem. And please do say, if the writing is too poor or too small or anything, let me know. We'll try and fix it. I got some other pens as well. So let's start off by looking at, this is from page 130, exercise A, and we have A2. So exercise A is all about proving various sentences or theorems. So our first one here, we've got this sentence. Okay? N disjunction not N. And we're going to prove that it's a theorem. So if we're going to prove that it's a theorem, what's the first thing we're going to do? How do we start?
Draw a line above the sentence.
Yeah, right? So we're going to, well, this is where we want to end, right? So our first move is going to be, right, we're going to draw our assumption line, and we'll draw our proof line down, and our first numbered sentence is going to be below the assumption line. This is basically what you mean, right? Below the assumption line. Because in this case, to prove that it's a theorem, we do not get any assumptions to work with. We have to literally bootstrap it from nothing at all. So that's how we're going to start. And we know where this sentence, or sorry, this proof is going to end, right? It's going to end in this disjunction. So, thinking about where we know it's going to end, what kind of rules do we suspect we'll use last? Let's start using this sort of bit of advice I gave you earlier. Looking at where we're going to end, what rule sort of suggests itself as a final step? Well, let's be really just blunt, right? Again, one of the things you can do to help yourself out here, if the conclusion has an operator, think about using the introduction rule for that operator, right? So in that case, what's the main operator of this sentence where we want to get our would-be theorem? Yeah, right? Does everybody see the idea? So let's think about disjunction introduction. And again, we're just planning here, we're not committing yet. But if we do disjunction introduction as our last move to get us this sentence, what would we need beforehand? What would we already need in the theorem, or sorry, in the proof to get this sentence using this root?
We need N and not N.
Do we need them both?
No.
No, we only need one, right? If we had N, we could get this sentence using disjunction introduction. Because remember, disjunctions are cheap. If you have one of the two, you can bolt on whatever you want. So if we had N, we'd be money. Similarly, if we had not N, we'd be money. Everybody see that before we take any more steps. Make sense? Okay. Now, at this point, right, we know if we had a sentence or its negation, we could get to where we wanted to go. This should set off massive, massive, massive alarm bells. There's a rule perfectly designed for this. What rule does this immediately just kind of scream for? No? Okay, that's okay. What do we think? Yep.
Contradiction introduction.
So that would be if we had them both, right? But note, if we had them both, we'd already be done. So I like it. That's one that should come to mind. But note here, we're basically saying if we had N, and if we had not N. It's the wankiest named rule, right? It's the one with the stupidest name. Tertium non datur. No third way. No third way, TND. It tells us if you can derive a result from a sentence, and you can also derive the exact same result from that same sentence's negation, then you know the result is true. So, what can we do for this proof? Well, we're going to use TND. Tertium non datur. No third way. And it kind of lines up. So it's, again, a friendly bit of advice. A pro-gamer move, you might call it. If you're proving that a sentence is a theorem, 99.9% of the time, you have to start by opening a subproof. So this should immediately suggest some rules that introduce or require introducing various subproofs. So in this case, what we'll do, we'll use TND. We want a proof that starts with n and ends in a result. And we want a second subproof that starts with not n and ends in the exact same result. So let's think about it, right? If we start with n, what result can we get to that we could also get to from not n? Well, let's spool back for a second. Remember, what did we say right here? Right? If we had n, what can we immediately derive?
N or not N.
Yeah! Fuck! Right? Cool. Bang. So we can use disjunction introduction to get us that disjunction. Because again, disjunctions are cheap. If you have a sentence, you can bolt on anything you want. Cool. Are we finished with the proof? No, we're Bon Jovi, right? We're only halfway there. We need to do the other half. So with that in mind, what's our move at line 3? What do we need to do at line 3? Yeah, a subproof starting with not n, and it needs to end in the exact same result as our first subproof. So what's our second subproof going to end with? So let's start our second subproof with not n, and it's going to need to end in the same thing that the previous subproof did. So with that in mind, what do we think we're going to do at line 4? Well, we know that this subproof needs to end in the exact same sentence as the subproof from 1 to 2. So what do we expect we're going to do at line 4? No tricks, yeah?
Just the exact same thing.
Oh, yeah, beautiful, beautiful. The exact same fucking move, right? But of course, what sentence are we using in this case? 3, right? It's disjunction introduction, but this time we're bolting something on to 3. Because 1, we're done with. It is dead to us. We cannot go back to it anymore. So we can still get n or not n through disjunction introduction, but this time sentence 3. Cool. So we've now done, bang, that bit too. Now then we're set. What do we do at line 5?
The TND.
Yeah, that's it, right? Now we use TND, and what's the sentence we get?
Is same as 2 and 4.
Exactly, right? We have shown with 1 through 2 and 3 through 4 that no matter whether n is true or n is false, you get to this disjunction. So either way, that sentence is true. And our rule is T and D. And our citation are the two subproofs. 1 through 2, and 3 through 4. And look, what have we done? We have derived this disjunctive sentence without any opening assumptions. Every assumption we used, we decommitted to by the end of the subproof. We have proven that that sentence is true without any kind of dependencies whatsoever. Okay. Now before we move on, pause, ask, what questions do you have for me on this first one? Please. Good. So the general idea with T and D is effectively to say, hey, look, for every sentence, in this case N is either got to be true or it's got to be false. Start with that. If it turns out that there's some result we can get to when N is true, and we can get to the exact same result when N is false, then it doesn't really matter. That result must be true. Because we know either N or not N, even if we don't know which. But if they both get us to, in this case, that disjunction, the disjunction has to be the case. Because this or this must be true. It's basically a version of disjunction elimination using a kind of hidden disjunction that for every sentence, it or its negation is true. So, before we move on, let's also do this one indirectly. So there's multiple ways to do this one. So let's do this one indirectly. We're going to start with the same. And our aim is, again, to prove that this sentence is a theorem. So how would we show that this sentence is a theorem indirectly? We talked about it about 20 minutes ago, 15 minutes ago, if we're generous. How do we prove something indirectly? Do we remember? Don't make me get the slides back up. Yeah?
To prove that there's a contradiction.
Close, right? So, I'll help you out. It's basically the right idea. We're going to assume the negation of what we want to get to eventually. And we're going to show that its negation leads to a contradiction. Assume it's false. Show that that leads to bad things. Conclude the sentence must be true. So let's start by assuming the negation of what we want. And now we want this subproof to end in a contradiction. We're going to conclude that the opposite of this must be true. So we want our subproof to end in an upside down T. Now looking at sentence 1 here, does that set off any alarm bells? You said it earlier, my man. What does this look like? What rule do we think we should use here? De Morgan. Right? De Morgan. If you see a negated disjunction, the first thing that should come to mind, let's De Morgan it. Because what happens if we apply the De Morgan rule to this? Sorry, I didn't mean to scare you. I just remembered that you said it. If we apply De Morgan's to this, what do we get? We get not N and not N. Interesting. Remember, we want the subproof to end in a contradiction. we pretty much got it already, right? We're 2 steps away from it. So what can we do to give us a contradiction inside our subproof? Yeah. Well, we can't do that. So in order to do D and E, the 2 negations need to be the main operators. And there's at least one thing in the way here. What's in the way? The conjunction. So, let's get rid of the conjunction, right? Conjunctions, easy to eliminate. Because what does conjunction elimination give us? It gives us the conjuncts, right? It gives us the conjuncts. So let's do conjunction elimination on 2. If I run it once, what can I get if we do conjunction elimination on 2?
Not n.
I can get not n, that's one of them. What else can I get from conjunction elimination on 2? Not n. I heard somebody. And hey, what can we do now at number 5?
Double negation.
Here's the neat thing. We don't even need to. Why do we not even need to? Because remember, what are we looking for our subproof to end in? We need a contradiction. And in order to do contradiction introduction and or negation elimination, same rule, just 2 different names, we need a sentence and its negation. Do we have a sentence and its negation? There's our sentence. There's that same sentence being negated. We've already got our contradiction. We don't even need to do DNA. So we can now do that. And what's our rule? What's the rule to give us the contradiction? And here again, it's helpful to check the rule sheet.
Negation elimination of 3 and 4.
Yeah, exactly, right? Negation elimination on 3 and 4. No, I don't care about the order here. Go nuts. Whichever way you want to write it. And hey, look, our subproof has done its job. We started with the sentence, derived a contradiction. So now, what can we do at line 6? Why did we want the subproof to end in a contradiction? What was the big rule? The big idea at line 6 was to do negation introduction. Because what we can now introduce is a negation on the sentence we started our subproof with. 5. And now, the move you always make if you're proving something indirectly, the last step is you do D and E. And in this case, we get the sentence we want. Okay, don't worry, man. We'll work it out. So the important thing here, before we talk about the practicalities, right? There's what we did, right? But there's more importantly, what we're trying to do here, right? What's the general aim? If we're proving theorems, no, we did 2 different ways to prove the same sentence is a theorem. In both cases, what we did, we assumed nothing. There's no sentences above the provability of the assumption line, right? And we proved this sentence is still true from nothing at all. Bootstrap it into existence. So again, the general idea here, if we're proving theorems, is that you can derive the sentence from nothing at all. Please.
I'm very confused on what you did after step number 5.
Good. On this one?
Yeah.
Okay. So, this was an instance, again, of this sort of idea of proving something indirectly. And the concept with proving something indirectly is you assume the negation of the results you want to get. Assume the sentence you want to derive is false. And then, from that negation, you derive a contradiction. Effectively saying, hey, if this was false, bad things would happen. And then you say, cool, so it must be true. But of course, we can't really do that in our natural deduction system. So instead we say, hey, right, this thing leads to a contradiction, so its negation must be true. That is, we get not the thing. And then finally, our last move is to, of course, if we know it's not, get rid of it. If we could just kind of do that immediately, we wouldn't need to have this weird little two-step move. But again, this is a limitation on the rules we're allowed to do. But the conceptual idea is we say, this sentence, right, if it's false, bad things must happen, so it must be true. That's the kind of general idea.
Could you explain the difference between contradiction, elimination, and negation introduction?
Yes. Good. So, contradiction elimination, you mean? So, contradiction elimination isn't technically a rule that we have. What we have is, we have contradiction introduction, which is the same rule as negation elimination, which is what we did here. So, what that rule says is, if you're on a line and you have a sentence and its negation, then you have a contradiction. Now, notably, in that case, you get the upside down T, but it does not move you on the line. You stay on the same line that you are currently on. Contrast that with negation introduction. What that does is you need to have a subproof that starts with the sentence you want to eventually negate. And you say, cool, if it were true, bad stuff happens, so it must be false. Again, in this case, it's a little weird because the thing that's false is something that's false, so we get the flip. But again, conceptually, that's the important point. Does that help at all? Okay, cool. Okay, so again, if we're proving theorems, the big aim is to try and show that we can get this sentence from no assumptions whatsoever. We're going to do more. We'll do more on Thursday and Friday. But this is the big point. So let's talk about the next kind of proof-theoretic concept that we can track, which is provable equivalence. So this is exercise C, also on page 130. And again, I've asked you to do the odds for the homework. So let's look at one of the evens. I already did 2. That was the example we did. So let's do C4. In C4, we have these two sentences. We have U conditional I, and we have negation U conjunction not I. And we will show that these are provably equivalent. So the first question to ask is, if we're going to show they're provably equivalent, how many proofs do we have to give? 2. Right? We got to give 2. One that starts with the left and ends with the right. One that starts with the right, ends with the left. Make sense? Cool. Okay. So, let's think. Which way do we want to go first? Left to right, right to left? We got to do both, so it don't matter which way.
Left to right.
Left to right's fine. All right. Let's start with left to right. So we're going to assume our left-hand sentence, and we want to end with the one on the right. So based on that, looking at this sentence on the right, where we want to end up, right, what rule do we think we'll use last? Let's start with, yeah.
Conjunction, conditional introduction.
So if we're starting with the left-hand sentence and we want to get over here, right, there's no conditional, but I think you're probably just using the wrong name.
No, I think I'm just confused.
Okay, it's okay. Again, so the first move that we need to do, we need to start with the left-hand sentence and derive the right-hand sentence. So again, we're going to start with this one, and we want to derive this one. Our proof needs to end. So looking at this one, what rule do we think we'll use last? Here's the general thought. Place to start. Look at your conclusion and think about using the introduction rule for its main operator. So in this case, what's our main operator for our would-be conclusion? Negation. So let's think about doing negation introduction. It's not always guaranteed to work, but it's a good place to start. So if we're going to do negation introduction, what does that require? Well, hey, we even have an instance of it over here, right? We'll need a subproof that starts with the sentence we want to eventually negate and ends in a contradiction. Everybody with me so far? So if we started a subproof with U conjunction not I, so basically imagine this in here. If we started a subproof with this, is there any way that we could get to a contradiction? Well, here's the trick. To find a contradiction, we'll need to derive a sentence and its negation. So another pro tip, right? Start negation hunting. That is, look to see what sentences do you have that are already negated. In this case, again, if we'd slot this in here, do we have a sentence that's already negated? We've got not I, right? And it's underneath this conjunction. But the conjunction's fucking piss easy to get rid of. So we can get not I easy. Could we also get I? Money. Let's do it. So we're going to start by opening a subproof. Again, the idea with this subproof is we want it to eventually end in a contradiction because we want to do negation introduction at the end. With me? Okay. So since this sentence we want is that one, we're going to start with its unnegated form, eventually to introduce the negation. Now, to get the contradiction in this subproof, we're going to need a sentence and its negation. That's going to be I and not I. So how am I going to get I? How do we get I, the unnegated sentence? What's in the way? Conjunction is part of it. Okay. What else? Nice. Right? If we look for the sentence I, it's right there. And there's its negation. So we're going to work with both of those. One of them's easy. One of them's real easy. It's behind the conjunction. So we just quickly get it. Let's go ahead and give ourselves not I. And what rule can we use to give ourselves not I? Conjunction elimination, right? So again, the general idea here is if you have a conjunction, then you know that the conjuncts must also be true. Now we need I. And what are we going to do to be able to get ourselves I?
I'm not sure.
It's okay.
Negation.
I like the idea, but negation elimination only ever gives us a contradiction. And if we're already at that point, we'd be done, right?
Okay.
Because that's what we want our thing to do. But let's look and see. Here we can help ourselves out again. We want to get I. What operator is in the way? What's in between us and that atom?
The conditional.
The conditional, right? So we need to find a way to eliminate, to go through this conditional. Does everyone see the idea? So in order to eliminate a conditional, we need a conditional. What else do we need?
The antecedent.
We need the antecedent. Can we get the antecedent here? How do we get it?
Conjunction.
Right there the whole time. Now, we're very set. Because what can we now do at line 5? Why did we want you? That's not a good thing to say on camera. Why did we want this sentence, you? Yeah.
To get the I from the U condition.
Exactly, right? Because now we're set and we can do conditional elimination just like that. And hey, look, we've got our contradiction. So now we can come back just like you suggested. We can do negation elimination, which is always negation elimination results in the contradiction, right? It always gives you that upside down T. So if we do negation elimination, we get our upside down T, and what's our citation here? So we're using negation elimination. What's the 2 sentences we cite?
3, 5.
Yeah. Cool. And now then, we're almost there. What's our move at line 7? What do we do now? Why did we want the subproof to get us to this contradiction? What was the plan?
Negation introduction.
Exactly, right? Negation introduction. We've set ourselves up now. The subproof has done its job. So now we can close it, be done with it. It is dead to us. Thank you very much, buddy. You did your job. And we can do negation introduction. Negation of the thing that we started our subproof with. So negation, introduction, and we cite this subproof. 2 through 6. Okay. And before we move on, first thing to ask. What questions do you have for me on this proof? I also want to say something. This is useful, especially before we get to the FOL stuff next week. It is worth stressing. I'm going to say it, whether it actually sticks is another damn thing. Do not feel embarrassed to ask questions. Do not feel embarrassed to make suggestions that don't work. That is the most useful and helpful thing that you can do. Don't sit there and be afraid to say stuff. Because honestly, that's just going to mean you're probably not going to learn what we're trying to do. Right? It's better to try and fail and then try again better than to not try at all. Silly things, but it's worth saying, especially with this stuff, especially in a room like this. Right? I very much understand and appreciate it. But it is really important and worth saying. So, coming back. More generally, what we've done, we have constructed a proof that starts with our left-hand sentence, and we've derived the right-hand sentence. Are we done answering the question? Nah, we're Bon Jovi'd again, right? We're only halfway there. We got to do the right to left. So, let's think about the right to left. Let's think about the right to left. How might we do this? This one's hard, isn't it?
Maybe do negation introduction again, so you can get rid of, you can make a double negation and you can get rid of the bracket.
I like the idea, but remember, in this case, what we want our proof to do is we want it to end up in this one, right? We want our proof to end up in this one. So what we're thinking of there is kind of just manipulating this sentence, and it might help us. Right? Yeah?
Is it just the other one? So in the previous one, the 2, is that the first one, the other one, is that down 1?
Kind of.
Conditional I.
But no, so this is where we want to get to, right? This is the sentence we want to get. Effectively, right, we did left to right, now we got to do right to left. So this is the result we need, the proof we're starting over here. So let's start really simple, right? Let's look at the result we want, our conclusion. Let's start the same way I've suggested with every single one of them. Looking at our conclusion, what rule do we think we'll use last? What's the main operator in the would-be conclusion?
Conditional.
So let's think about conditional introduction, just for shits and giggles, okay? If we're going to do conditional introduction, what do we got to do? What's conditional introduction require? Here it's helpful. Look at the rule sheet. I'll help you out. Right? Conditional introduction requires a subproof that starts with your would-be antecedent and ends with your would-be consequent. That's just what the rule says. So let's think. If we had a subproof that started with started with you, that started with this sentence, could we get to I? Interesting. How could we get to I? Well, let's go ahead. We'll copy this first bit in, right? I like the idea. So we're going to start a subproof with you, and the subproof needs to end in sentence I. All right. Now, if it's going to end in sentence I, how might we get ourselves to that? I like that idea. So notably, right? If we're thinking about contradiction, right? If we could somehow get I and not I, or you and not you, that would help. I like that thought. Talk me through it. So how could we get ourselves in a position to do something like that? Well, here we go. Let's think about this for a second. I like this idea, so let's pause it, but we'll come back. If we look at what we have at line 3, right? We're at line 3. If U is true, what couldn't also be true? Given what we're working with here, if U is true, what must also not be true?
Not you.
That's one.
Negation.
Not U, negation U.
Not I.
Why that? Why would not I also need to be false? Yeah, fuck, right? If not I were true, wouldn't we have a contradiction? Does everyone see why we'd have a contradiction? Cool. So if not I must be false, what must be true? I'll say that again because that's real awkward. If not I must be false, what sentence has to be true? I. We now know how to get to I. We will start a subproof with negation I. We will end in a contradiction, and we will then derive I. Do we see it once we get it? It's beautiful. It's okay. We'll walk through it, right? So for step 3, we are going to open a sub-subproof. The aim of the sub-subproof is going to be negation introduction. We want to introduce double negation I. Because again, the aim of the game is for the big subproof, the one that starts at 2, to end in I. Okay? So we want to start this with not I. And we want to have this get us to a contradiction. So what can we do at line 4 inside our sub-subproof that is going to get us a contradiction? What sentence can we generate at line 4? You said it a second ago, right? What can we build at line 4? Oops, that's bad. Yeah,
I have a question.
please.
Why didn't we start with you, conjunction, negation I?
Good. So in here you mean.
Yeah.
So notice again what we want to do, right? The big task. The big task for the whole question is to show that these two sentences are provably equivalent. So one of our sentences is the negation of this conjunction, and the other is this conditional. In order to answer that big question, we need to give 2 proofs. One of them that starts with the left and ends with the right-hand sentence. And now we're starting with the right-hand sentence and trying to end with the left. So we could have tried to, okay, let's assume the unnegated version of this, but it's not clear how that necessarily would have gotten us any closer to getting the eventual conditional. It's okay, it's a good question. Yes?
Would you have been allowed to use the X rule thing?
So we could try, right? And again, this was the sort of suggestion. And there's a version of this that uses explosion. But importantly, explosion only ever keeps you on the same line. We're always going to want eventually to get something that's back on that main proof line. So we're going to need some rule that lets us beyond, say, to the left. Right? Explosion doesn't do that. It's extremely powerful, but it's constrained. Right? It keeps you on the line you're on. So, okay, spooling back. At this point, we have built this conjunction. And this conjunction, together with what we have in line 1, gives us a contradiction. Now, why did I want that contradiction? What can we now do at line 6? What's our move at line 6? Yeah.
Negation, introduction.
Nice. And what am I negating?
Double negation.
Nice. So we get not I through negation introduction, 3 through 5. Again, this sub-proof shows that if not I were true, bad things happen. So not I must be false. But of course, if not I's false, what sentence must be true? Write it again, right? I does. Right? So for line 7, we can get rid of the double negations. And get I. Okay, now we are almost finished. We've got one more step. What is the last step? What's the last step? What is all of this in service to? Move at line 8. Yeah? Exactly. We are now set to do conditional introduction because we have shown if U is true, that's what we assumed at line 2, then you can get to I. That's what we got at line 7. If U, then I. Oh, that's very sweet. Conditional introduction, 2 through 7. Now, before we step back generally, yeah.
Instead of starting line 2, the letter U, we start with the letter I.
Good. So we could try, but note that if we start with the letter I, we're not then going to be able to do conditional introduction to give us this sentence.
So we start with which is more comfortable for us.
So importantly, in this case, we had this idea of doing conditional introduction as the last move. And again, the kind of motivation for that was looking at where we wanted to get to and thinking about the introduction rule for its main operator. It gave us a way to get started. So the introduction rule for that operator says a subproof that starts with your would-be antecedent ends with the would-be consequent, not the other way around. Good question. But we could do it another way too. There's plenty of ways to get here. So, yeah, please.
Proof and subproof of not I that if it's true it will be a contradiction. Why the double negation then?
Good. So here's the kind of funny thing. I mean, when I'm talking about it, I say things like, oh, if not I's false, then I must be true. This is fast and loose. Because you notice, in this natural deduction stuff, we never talk about sentences being true or false. We don't have valuations. That was what we were doing with truth tables. Instead, what we really have is if you have this string of symbols, you can manipulate it in this way. So the closest kind of thing we can get to this, oh look, if the negation's false, then the sentence must be true, is this. We can show that the negation leads to bad things, so the double negation must be true. And then we have the rule that lets us say, hey, if you've got 2 negations, you can erase them. It's an interesting thing, and this is, I don't want to complicate it, but there's plenty of variations in logic, and this is something we'll talk about right at the very end of the course, that drop this rule. Because they allow for truth value gaps. So if you had truth value gaps, then the negation being false wouldn't necessarily mean that the sentence is true. But we've got that assumption, so we can go from not to get us the sentence. But this is the best you can really do. You don't have truth and falsity. You just have syntactic manipulation. Does that help at all? Okay. So, we got through 2, which is good enough, and we'll talk some more about showing that sentences are jointly contrary. So we'll talk about these on Thursday and Friday. But note again what we do. If you're proving a sentence is a theorem, you take no assumptions, derive the sentence. If you're proving two sentences are provably equivalent, two proofs, left to right, right to left. So let me quickly just go back and say, do this. Yeah, just really quickly, one last thing. So what we're going to do next, all of this was warm-up. All of this is basically the warm-up sets. Because the next thing is FOL natural deduction. This is what I really want you to learn. So what we're going to do next week is I'm going to teach you all of the rules for FOL natural deduction. Between friends, there's only like 5 more rules. So it's not crazy. But of course, it means that the proofs are going to get a little more complicated. It's okay. So what we're going to do this week on the tutorials, again, we're going to talk through this stuff. Make sure we're all okay with it, and in order to prep for next fun week, where we do FOL natural deduction. Thanks for coming, guys. Take care of yourselves. I'll hopefully see you all Thursday and Friday.